The purpose of this video is to derive the understanding for casual, non-casual, and anti-casual for you. So at least when you revise, you understand the meaning of whatever stuff it is. Alright, but before I start off with the definition, I'll start off with something that is familiar to you. This is your output. Alright, this is your input, E, and this is your transfer function, if you still find it familiar. Alright, if it's not just info, this is output, this is input, this is transfer function. If your input is an impulse, alright, this means that your UZ, your output, is equals to your transfer function, HZ. Alright, and this is particularly useful when you're talking about your controller. If you want to test your controller transfer function, you can actually set the input, impulse input. You can see whether how your transfer function is being performed in real life or whatever. Okay. Nonetheless, you can also have a transfer function as your plant. Alright, so you can run the system and see whether your plant is good or not. Alright, given impulse input over here. Okay. Nonetheless, you can also put the controller and plant together and see how they works with the impulse input also. So as you can see, impulse input is very important, and therefore in this video we also use impulse input later on to prove to you certain stuff. Alright, for the casual stuff. So let's start. Alright, easy over here is, remember, is the input. Alright, it comes from EK. If you were to Z transform EK, you have EZ. Alright, the Z transform states that you are taking from 0 to infinity. Alright, and then Z minus K. Okay, this is the Z transform using this stuff. Alright, so if that's the case, if K is equals to 0, I have U0, Z0, plus if K is equals to 1, I have E1, Z1. If K is equals to 2, I have E2, Z2. Okay, so I'll just simply sub in my K and K over here. Okay, with a minus 1, minus 2, sorry. Alright, and if Z is 0, alright, this is simply stating that it is Z to the power of 0 is just 1, so it's just E0, that's all. Okay, and so from K is equals, I should say that when K is equals to 0 all the way to infinity, so it's all the way to infinity. Okay, when it's at E infinity, Z minus infinity, something like that. So this whole thing over here is this thing over here. You take a time to just double check, it's the same. Alright, and therefore knowing these definitions, alright, I'll not go on to this one because it's exactly the same. Alright, EZ you can transform is this one, your HZ is something this one. It's the same thing, the trend are all the same. Alright, and then you take E0 multiplied by H0, E0 multiplied by this one, E0 multiplied by this one. You do those similar multiplication like A plus B and then C plus D, and then you multiply each other, expand. When you expand, you will have all these things. E0 H0 plus all this stuff all over here. You just group them all together. Alright, so I'm just simply grouping your E0 and H0 all together and multiply them together. Alright, and I forgot to say this, that E0, EZ, HZ, if you were to multiply them together, you are just telling them that it's a convolution. Alright, it's called a convolution. Multiplying is just a convolution, that's all. Alright, but anyway, let's continue. So if you were to multiply everything, you can somehow group them by their powers. Z to the power 0 is just 1, right? So it's E0 H0. Z to the minus 1, this is Z to the minus 2, but they haven't factorized it out. Alright, but anyway, later on you have Z minus 3, Z minus 4 with whatever constants inside. Alright, so this constants, I can say that it is U0. This constant over here, I can say that it is U1. Alright, after I factorize out Z minus 2, this constants over here will be my U2. Okay, if you were to compare, alright, E0 H2, E1 H1, and H0 E2. Alright, so therefore I can simply say that this whole thing is just U2. Alright, so I've proved to you that U0 is equals to E0 H0, which is written over here. U1 is equals to this one over here. Alright, the purpose is to show you different stuff, so that at least you get a feel of things. And therefore I have all this series. What I can do is to write in terms of a geometry series, as a summation series, I would say. So your UK is equals to blah blah blah. And how does this thing link to this, or this, or this? So I'll just test out with the U2, for example. Alright, So it states that from j is equals to 0, you all the way goes to k equals to some value. So if I have my k is equals to 2, so therefore let's start off with when j is equals to 0. Alright, so maybe I should write as u2 for example, when k is equals to 2. So therefore I can write as e0, alright, when j is equals to 0, and k is equals to 2, what I have is e0, h2 minus 0 is simply h2, right? So I have this thing over here. So you have somewhat built up the first term, e0 h2, plus, if j is equals to 1 now, alright, then your k is equals to 2 still. Alright, so e1, 2 minus 1 is just 1, so I have e1 h1. Okay, e1 h1. If I were to sub in as j equals to 2 now, I have e2, where k is equals to still equals to 2, and j is minus 2. Alright, so j is 2, sorry. Then is 2 minus 2 is equals to 0, so I have plus e2 h0. So I'm just simply spending from j is equals to 0 to 1 to 2. Alright, so therefore if I were to sub in, this is k equals to 2, j is equals to 0. This is when k equals to 2, j is equals to 1, k equals to 2, j is equals to 2. Alright, each of these terms are orders. And these terms over here is your this thing. Ta-da! So your u2 can be re-represented as this thing. But this is overall, at the overall scale, this is your geometry. Alright, this is your overall you can represent anything based on this thing will do that. Alright, now this is where the input comes in, the impulse input. Alright, this is the graph, 0, time. Alright, this is the time axis. Alright, we have 1, 2, 3, 4, etc. Alright, so if your input is 1, which is your e, alright, these are all 1s now. Okay, but there's some information telling us. So at e0, which is at time 1, alright, at time 1 you have h2, some functions like h2, and then when at e1, alright, at time 1 you have h1. Sorry, what am I doing? At e0, which is at time 0, is h2, which is over here. And then at e1, alright, we're time 1, because e1 is simply 1, the magnitude is 1, but they are just telling the person that, alright, at time 1, there is an input of 1 into your transfer function h1, so output is h1. So at time 1, I'll have output of a h1 over here. Alright, it may be here, it may be here, it may be anywhere. Alright, your h1 can be here, it can be here, it can be here. Alright, but I just want to plot it out. Alright, same thing for at e equals to 2, your time is equals to 2, your magnitude is 1 because your input is 1. Alright, multiply by h0. So at time 2, you have h0 over here, for example. So your u2 can be comprised of this particular signal. You see? So you have this piece of signal and then you can see what it is. Alright, this is particularly for your u2 case. Alright. So as you see that your u2 can be comprises of 3 signals, 1 signal, 2 signal, and 3 signal. Now if you were to extend these definitions, alright, to these definitions, things go a little bit different, because you're not capping yourself at k, you're capping yourself as infinity. Alright, and you're starting from minus infinity. Okay, you're not starting from 0 as we see just now, you're starting from 0 over here. We are not starting from 0 anymore, we're starting from minus infinity. And this is called the discrete convolution. So take note, this thing over here is totally different from this thing. Alright, they are different. Alright, please take note of that. So using the same thing, alright, we're still gonna use k equals to 2. Okay, when k is equals to 2, for example. So u2 in this case is, alright, the first series is from minus infinity. So I have some minus infinity. Alright, h. So 2 minus infinity, you know that it's minus infinity because minus infinity is so large. Like for example, 2 minus 1,000 or 10,000, you can round off and get back just I think you get what I mean already. So minus infinity. Maybe I should just write as 2 minus infinity in case you feel blur lah, okay? Like this. Plus, alright, blah 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 blah, maybe plus blah 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 blah, okay? All the way to, for example, if I were to sub in j as 2, for example. Sorry, minus 2. If I were to sub in j as minus, so this is when k is, maybe I should write in a different color. When k is equals to 2, j is equals to minus infinity. Okay, this is for this term over here. Now if I were to sub in different j, alright, if I were to go all the way to e minus, alright, if j is equals to 2 now, alright, e minus 2, h, 2 minus 2 is equals to 0, right, so it's equals to 0. So this means that when k is equals to 2, j is equals to minus 2, then you have this thing over here. Okay, you get what I mean? So so we are still doing k equals to 2, but the j is varying from minus infinity all the way to j is equals to infinity. So I'm trying to prove to you something of that meaning. Okay? So as you can see, at e minus 2, you have a h naught over here. Okay, and blah 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 plus, if your j now, alright, is maybe 3, or if your j is equals to 2, sorry, if your j is equals to 2, for example, alright, what do you have? You have maybe a different color again. I'll have e2, alright, if k equals to 2, j now is equals to 2 now, alright, h, so k equals to 2 minus 2, what do we have? We have h naught. Alright, actually this one is wrong lah. This should be h4, alright, because when k is equals to 2, minus j is minus 2, so minus 2 is actually 4, so this over here should be h4, my fault. But anyway, at least you get to see some picture of it. Alright, all the way, if you were to just say that is if e infinity, h infinity, so when k is equals to 2, j is equals to infinity, then this is the whole series. Alright, you see u2 comprises of all this stuff, where your u2 just now only comprises of these things only. You see there's a big difference. If you were to plot this thing, alright, at e minus infinity, which is at time in minus infinity, for example, minus infinity, alright, you have some h2 minus infinity, alright, and then at j equals to minus 2, which is somewhere over here, alright, you have h4, and then at e is at time 2, you have h0, and then at infinity you have some infinity, h infinity. Okay, so you have all this curvature, all this line in a discrete convolution system. Alright, given that you know that your input is still an impulse input lah, so that's why the magnitude of all your e's over here are all ones. Right, but just to indicate that they are in terms of time, minus infinity, minus 2 and 2. These are all the things. Alright, now the next thing is to inform you that this portion over here is a real system. Why is it a real system? It is because your time starts from 0 to something, right? Do you have any time that is negative? Alright, there's no time that is negative. You only have a time that is starting from 0 all the way to infinity. Alright, so that's why this portion over here is a real system. While this over here, this negative stuff, are somewhat your haven't happened yet. Alright, this system over haven't happened yet. But why do I say it's haven't happened yet? It's because if you were to move your axis, alright, if let's say at maybe as your time goes by, alright, this thing over here, your whole axis may actually shift. Alright, maybe I should, yeah, your whole axis may actually shift to here, maybe over to here, okay? So maybe I should use a thicker line. So in the future, alright, at some future time, your origin will be moved to here instead of here, as you can see. So you actually move to here, and therefore our h4 becomes a real system now. You see? Then as you goes by with your axis, alright, go more and more further. Alright, hold on a while. Alright, this is the origin now. Alright, you have moved your origin to this part over here. Then you have more and more negative become positive. Alright, because all their time has changed. Alright, all this stuff has all changed because all of them now is all real. So your whole axis, if your whole axis is moving, alright, then this tells us what? Alright, this somewhat the events that happens over here, alright, these events that happens over here will be a future events. Alright, as time goes by, alright, your future events will come into play. Although in this particular time zone, these are real, but at other times, this thing over here will soon become real. So that at least you get a feel that this future events may actually happen in your real life. So you also can help to predict your future events. Alright? And with this said, alright, let's go into the definitions of a causal system. A causal system states that output depend on the past input and current input. Alright, a causal systems only settle for the system, a real system, because you are dealing with your past input and your future input, for example, h infinity and past input. And then you add them together, you divide it by their time, alright, you'll get your whatever thing that you want. Okay? So it's only dependable on the real system, that's all. A causal system is dependable on the past input and the current input. For a non-causal system in such of a case, alright, you're dealing with both the real and the future input. Alright, so it's whole thing all together. So what we have been doing for this case, this thing over here, alright, where you're from j equals to minus infinity to infinity, you're talking about non-causal system. Alright, you deal with your past input, you also deal with your current input, you also deal with your future input. Alright, your past and current input are all these things over here. You also have your future input all over here. Okay, so your output is all dependable on what type of stuff, while your anti-causal is simply dependable on only on your future input. So your anti-causal is simply only this. So just to repeat again, alright, your causal input or your causal output is simply this one, real. Your non-causal system is both of them. Your anti-causal is only future. Alright, so I hope that this is a pretty good explanation. And your output is dependable on your past input and current input, and your output is dependable on as you can see, is all output dependable on what? Alright, and the output is simply your output, your UK. Your U, if you remember, U is equals to output, E is your input, and your H is the transfer function. You get what I mean? So everything comes into more sightedness now. Alright, so your input and your input, current input, whatever, is based on the transfer function, based on different states. At different time state, you have different graph, alright, you have different points. So you link them all these points, alright, you'll give out your output. So these are all your outputs, and you get to see the full trend. Alright, because sometimes the future may give you a certain understandings for the next stuff. Alright, the future is a very important prediction, alright, to help you predict the future events that may occur. So non-causal system is some sort of the way. Alright, and therefore if you read it up, alright, the non-causal cannot be practically realized because it haven't happened yet, but it will soon happen, something like that. Alright, and the rest you can read it yourself because I don't understand what it's trying to mean, but at least I hope that this is a pretty clear understanding for the causal part. Alright, see you soon.